Hey guys, in this video we're going to go over programming your own RFID tags, which are MIFARE Classic 1K tags, to use in the Creality CFS or printer, because the printer has RFID on the side. What this basically will do is, if you buy these little tags for about 20 cents, I think you can get 100 of them for like $20, whatever. You can write data to these, stick them on the sides of the spools, and then when you put the spool in, it'll automatically detect what type of filament that's in there if you're unsure of what it was all about. Creality sells their spools with little RFID tags on the sides. So there's one on either side of the reel, because on the CFS the readers are on the two inner fins. So if you put it on the far edge, it'll read from this side. The next slot over, it'll read from that side. Next slot over, and so on. So putting a tag on either side of the reel just allows you to put the reel anywhere. Now I've made two different codes to do this. I've made an Android app so you can program the tags. That'll be on Google Play. The source code will be on my GitHub. And I've made an Arduino code that uses an ESP32 and the RC522 reader. You can pretty much pick these up from most electronic shops. And there's a little piezo speaker in here. You don't need this, but I've just added it so it makes a noise when I scan the card. The idea here is that this will just program the tag. It won't read on this one anyway. This hosts a web server, so you can modify the settings. So you'll be able to connect to this with your phone or your computer. This will broadcast a Wi-Fi access point, so you can connect to it directly with your phone or your computer, but it also has options in there so you can connect it to your home Wi-Fi. So when you first set it up, you'll connect to it with your phone or whatever, and you'll program it with your home Wi-Fi connection, and then this can basically just connect to your home Wi-Fi, and then you can control it from any device in your house, because it's a web page. So this will allow you to operate it with iPhones or pretty much any platform. As far as I know, Apple doesn't support, the iPhone doesn't support the MIFARE Classic card tags. I'm not an Apple person, don't know. So this basically covers what I've got around the house anyway. And again, the code for this will all be on my GitHub, so we'll get into messing around with it anyway. So on the Android app, it's fairly simple. You just select what type of filament you want. You can select color. You can sort of just drag the color you want, or select a preset one. You can select generic or Creality. Obviously, Creality's already got their filaments on there, but you can buy Hyper PLA spools that don't have RFID tags, so this just gives the ability to tag them. But we'll just go generic, and then we'll just say TPU, and then we'll select, I don't know, purple, and then you can select the size, and then I'll just turn that off. This will allow you to auto read the tag on scan. But if I put it there, it'll change the settings. So you put the tag there, and then you just hit right, and that'll have the information on the tag now. So the Android app's fairly simple. So when you put your sticker on the side of your spool, you can come along and then program it. You're good. These are rewritable, so you can take them off, put them. You can 3D print something. You can pop onto the side of the spool, and then once it's finished, you can pop it off and stick it onto another spool if you want. But they're 20 cents each, so they're fairly inexpensive. But we'll have a look at the Arduino code, because that runs through a web page. Alright, so onto the Arduino code here. I've just got it loaded up in a web page. It's fairly simple. It's pretty much exactly the same as the Android app. I've tried to make them as similar as possible. Here we just write, so we select a brand, PLA. It's exactly the same as the Android app. So we'll just select that, and then we'll go down, we'll say pet, your length there, and then we'll select purple as a color. If you want to select a different color, you can go to other, and it'll allow you to drag around so if you want green or something, you sort of select that, and then so what that does, is it sets the settings, so you just hit apply. That'll write it to the ESP32, so now when you scan a card, it'll put that information onto this card, and that information will be on the card. So now I can come back to the phone, and then we can hit read, and there we go, PET CF and generic 1 kilo and green. So that's what I just put in on the web page. So yeah, so you can basically program it with what you want, and then, you know, scan your tags and you're good. And of course, if you want to set your Wi-Fi information and stuff, access point, passwords, whatever, you just click on the little clog here, and that'll take you to the settings. So you can put in, this is the access point, so you can put in the access point. The default here is just password, so you can change this if you want. And then your home Wi-Fi connection, so you put in your Wi-Fi SSID and then the password. And then the host name here is just the MDNS name for the ESP on your home network. So you can just go to http://k2.local, and it should bring up this page without you needing to work out what IP address the ESP is sitting on. So it just makes it easier for you to access the page without having to worry about what IP it is. Again, you can change this or you can leave it. It's totally up to you. Once you're happy with your changes, you just hit submit, and it'll save them. Then you'll be good to go. But we'll move on to the printer now, and just show you it actually interfacing with the printer and working. Alright, here we are at the printer. It's a little bit warm here today, so the printer's making noise. So I've got the phone here anyway, and I've got the printer with no spools loaded into it. So we'll just select the, just go PLA silk, and then we'll put the tag on the back, and then we'll write. Hopefully that's coming through. So now I'll just use the RFID slot on the side here because it's the easiest one to use. We scanned it, so now we come up here and it'll be PLA purple, which is what I entered in here, and shows that it's been detected with RFID. We can go red, say ABS, put the card there again, and we'll write. Data's written. Again, we'll just scan it, and it'll come up. So now it says ABS, and it's red. So the same will work as when you put them in through the CFS. It just gives you the ability to automatically set up your spools. Okay, let's get into the more of a technical side of things. Obviously this information here is going to be subject to change, or this is just my interpretation from what I've worked out by digging through the files and the firmware and finding as much data on this as what I could do. So basically what we have here is you've got 4 tags here. This is the information that is on 4 different RFID tags from my Creality spools that came with the printer. So this gives us a good idea of what to break down, because this is the official tag that we're working with. All of these files we'll be going through and looking at are located on Mount UDisk Creality user data box. So if you want to have a look in your own printer, that's the directory there that you need to go to, and TAN data is where this information resides, these tags. And then of course we've got remaining length, which we'll look into, color values, which is just the color values of the spools, you know, the color of the filament, and then the material type. Okay, and material type, so these ID numbers here, this defines what type of material you've got in the printer on the spool, and so this is in the tag, and this needs to match entry in a material database file, which is material database in that same directory before. And then when you come down into the file, you'll see, you look for base, and then you'll have an ID number. Now interestingly enough, the ID here to the ID that's being stored in the tag is 1 number off. So here it's 101001, but here it's 01001. Now this is the same ID. So when we're looking for the filament in the database, we're basically just removing that one. Not sure why they've done it like that, but that's how it is in the tag. So we can just take away the 1, and then we just put in the last 5 digits, and that'll give us the ID in the material database. Okay, so we'll go on further down the line. And then T2, T3, T4, T1 up here. This is just your different CFS boxes. So obviously T1 is the first box, second box, third box. You get the idea, and that's why I only have one CFS. That's why these are all blank. So we don't really need to worry about that. I've taken these tags and I've broken them down into the parts for the information that I can find. And this is the table I've come up with. So now if we go over to the material box info file, we can get some information on what's going on in the printer. Now, when we're looking at this file, rack material, this is the spool that's on the side. On the side of the printer, there's an RFID sensor. You'll see it marked in white. It's got sort of an RFID sensory look where the spool normally sits. This information here comes from that. And then we go into material. This is the box. So as we come down, we've got same material. This is just telling the printer that T1A has white PLA. T1B and T1D slots have a red color. So if you run out of filament, it can continue with another spool. So if you have the same material, same color, and you run out of material on one spool, it'll change to the next spool automatically. So that's basically just what this is. You don't need to worry about that too much for now. And then we come down to box ID T1. So this is where the information is going to be stored for the CFS. The slots in the CFS are referred to as A, B, C, D for the 4. So T1A will be the first CFS box and the first spool. T1B will be the first CFS, and so on. So T2 will be your second CFS, and yours, you get the idea anyway. You don't really need to know about this anyway. So we'll just get into how I broke down the tags. So what we do here is we're looking for markers here. So when I was trying to decode what was on the tags, I'm looking for what's in here to match what's on the tag. So here we have the filament ID, and then we can see the filament IDs here. They all match because these are all PLA spools, hyper PLA, and of course it's hyper PLA as you see there. So, and then we have that in there. So filament ID is your hyper PLA. Then you have the color. So the color this is a hex code for color. It's 6 characters, and then they've added a 0 on the start, maybe for alpha, whatever. They've got a 0 there, and then there's a hash in there, but we don't include that on the tag. So on the tag, we've only got the numbers or the digits. We minus the hash, but it does have the starting 0. So this is how you build the colors. This would be white. We're basically you just add the 0 to any color that you're putting in there. Again, I don't understand why they're doing it, but it's how it is. So now we go down to, we see vendor ID. So 0276, that'll be Creality because that's the spool I'm using. And of course we see that value in the tags here, which is vendor ID. So we can work out that part of the tag is vendor ID. And then we look for serial number. So we come down to serial number, which is there. And then again, we can see that in the tag there, and we can see that there. And then they have a reserve, which is obviously for future data. And then we have that on the end of the tag. Okay, we come on to filament length. As far as I can tell, this is in meters, because when you search for like the length of a 1 kilo spool, Google says that 330 meters is the rough length, and this is 165. So that's half of 330, and the spools that I've got in there are 500 grams, so that's half a kilo. So the way to work this out is just take 330, and if it's a 750 gram spool, then you 75% of 330, and that'll give you a number. This value doesn't really matter though. The only thing I can put this down to is that the CFS is using this value here to just get a base estimate on how fast to spin the spool, because as you take filament off the spool, the spin rate is going to change as it gets closer to the middle. So I'm guessing that it's just a base idea, because when I take the same RFID tag and I'll put it on two different spools, the printer goes through a loading detection method, or whatever you want to call it, and you will watch the printer when you put a new spool in it, and it'll sort of roll around, come back, roll around, come back, and do its thing. What the printer's doing there is it's actually measuring with the RFID tag on the side. It's measuring how fast the spool's spinning. So it pulls the filament off, and however fast the spool spins gives the CFS an approximate length. So as you see here, this is the same RFID tag that was set at 1 kilo, and I just taped it to two different length spools. One was 500 and one was a kilo, and you'll see that this is the red is the amount left on the spool. If you haven't picked up on this, as the spool goes down, this will get smaller and smaller to give you a visual idea of what's left on that spool, so you don't kind of have to look up and try and work out by looking in the side of the CFS. So they've done this here, but this is just loading the spool, so it's clearly evident that the printer is ignoring this. It's not using that information here anyway. So I can only put this down to, this is just a baseline from when you first load the spool. So if you've got an RFID tag or whatever, and it's a 500 gram spool, it doesn't really matter if you put 1 kilo on the tag, because it's still going to detect it as 500 grams or 165 meters. So obviously, if you're going to write to the tags, try and make it as close as possible, but it doesn't really matter. And the serial number, I'm guessing that all of the serial numbers for the Creality spools are all 01, but the only thing I put this down to is maybe it's so it tracks the length of the spools over as you change them out or whatnot. Not really sure, because they're not using it. So that's kind of how I've worked out what's going on in the tags. Okay, and I've got two last parts here which I don't really know the values for, which is the first 5 digits of the tag, and then this section here. I've only got 4 tags to play with, so this section's all the same. I can only estimate batch, which I'll explain in a second, and I'm not really sure how to do this. But when I hex edited the firmware for the CFS and went through it, locating the parts of the RFID, I've pulled out this part, okay? And this is the code, this is part of the CFS firmware code. And as you'll see, we've got month, day, year, and I'm guessing that that's contained in this section. And then we've got supplier, batch, and the rest of it. So supplier would be vendor, and then batch, which is why I've got batch here, is this the batch ID. And then we've got material ID, filament ID, so we know that's there. We've got colour and colour there, and then we've got length, filament length, and number, serial number, so that's there, and then reserve. So using this string builder from the CFS firmware, I can only put it down to being that month, day, year is here. So 24, I'm guessing, is 2024. Not 100% sure, because I kind of just can't work out how they've come to this. But these are strings, and that's a char. So the month is a char, and the others are strings. So there's something going on that's different when it comes to the month. Is it a hex char, or I don't know. I'm not too fussed, because that information really doesn't seem to bother the printer. It honestly doesn't, and it's not anywhere in here. So that's how I've pulled apart the tags anyway. Obviously, this might change, of course. If I find more information on it, then obviously I'll update the GitHub. But this is where I'm at the moment anyway. Yeah, and I hope that helps you sort out some RFID tags, maybe make life easier. I'll just quickly show, I've already uploaded the app. It's called Spool RFID onto Google Play. So if you want to just download the app, you can download it there. And I haven't set up the GitHub just yet. I'm still in the process of doing that, but that'll be all linked into the video description, same as the link for this. And it'll all be open source. I'm not interested in data collection, charging, anything like that. The whole lot will be there for anyone to play with, manipulate, make their own app. It doesn't matter. The idea here is just to get the information out and hopefully, push forward the community more. Maybe Creality might open source the tags a little bit better, or whatever might come of it. But for now, this is what we've got to work with. And of course, Creality, if they want to, they could stop all of this working at any time. Let's hope they don't, because it is handy being able to manage your own filaments if you've got boxes and boxes of them and you just drop them in. Let's just hope Creality sort of gets on board, maybe releases the keys for their own RFID tags so we could potentially reuse their tags, because you can peel the tags off the spools, or you could re-spool them with different filaments. So maybe Creality should look at that. For now, being able to use our own RFID tags is really cool. So yeah, I hope that helps you anyway.